Hi, this video is about converting grams, moles, and particles. It's a review. We've talked about this in class, but a little time has gone by, so I thought a review would do some good. All right, so first of all, we have three conversion factors, and the first one is called molar mass, and that is taking the atomic masses that are under the symbol on the periodic table, and then if it's for, say, sodium chloride, you would add sodiums plus chlorines together to get the molar mass, and the unit of molar mass is grams per 1 mole. Molar volume of a gas at STP, this is given to you in the reference packet, and it's 22.4 liters per 1 mole. And then Avogadro's number is 6.022 times 10 to the 23rd particles per 1 mole. Now, the important thing is to know when to use these conversion factors and what to do with them. Should you multiply or should you divide? And the answer to both of those questions is in the units. Molar mass's unit is grams per mole, and so that is used for converting between grams and moles. And the molar volume of a gas is 22.4 liters per mole. It's used for converting between liters and moles. And Avogadro's number, we're using the generic word particle, but in these problems, it's going to be atoms or molecules per 1 mole. Now notice they all have one thing in common. Whatever the number is, like 22.4 or 6.022 times 10 to the 23rd, and whatever that mass is that you're getting from the periodic table, that number does not go with the mole. The number 1 goes with mole. It's always per 1 mole. So that's one thing they all have in common. Now, once you figure out which conversion factor you need to use, and again, the answer is in the units, then you need to figure out, do I need to multiply or do I need to divide by this conversion factor? And the answer is in the units and how they would cancel. And so, for instance, here, if I had, say, 24.02 grams of carbon, and I wanted to go to moles, well, we're going to set up our little conversion box here. This is like it's in the numerator, or in other words, it's over 1. We want to put grams down here, and mole goes up here. And look what happens. The grams cancel. This is in the numerator, that's in the denominator. Now the number 1 goes with mole, and the molar mass of carbon is 12.01 grams. And so in your calculator, you're going to put in the number 24.02 divided by 12.01. You're dividing because it's in the denominator, and your answer would be 2.00 moles. All right, so if they had told you that you had, let's say, 5 moles of carbon, then you wanted grams. Now the mole goes in the denominator, so it cancels, and grams go in the numerator. Now, how many grams are there in 1 mole? Again, that number goes with the unit grams, 12.01. So here it's going to be 5 times 12.01 grams, and then you'll get your answer in grams. So do you see how to decide whether you multiply or divide? If this unit is in a numerator, put it down here in the denominator so it will cancel, and then the number goes with the unit and the 1 goes with the unit mole. If this number is in the denominator, you're going to take what's given and divide by that number. If your number is in the numerator, you're going to take what's given and you're going to multiply by it. And the same applies for the 22.4 in Avogadro's number. Okay, so this is what a problem looks like. How many moles are in 325 grams of ammonium carbonate? Well, steps to solving the problem. First of all, always start with what's given. Always start with what's given and use the unit that's with it. Pick your conversion factor so that your units will cancel and help you to get to where you need to go. You set up your problem so that your units will cancel, and then you calculate. So let's go back to this. We have 325 We have 325 grams of ammonium carbonate. So start with what's given. 325 grams of ammonium carbonate. Now, we want to go to moles. And so to do that, what we're going to need to do is we're going to need to pick our conversion factor. Grams to moles is molar mass. It's not a standard number. It's not a constant number. We're going to have to calculate the molar mass using atomic weights on the periodic table and our formula. But we know we're going to put mole in the numerator, because that's what we want, and we're going to put grams in the denominator. So we write down what's given, we go ahead and immediately put grams down here so it will cancel, put the 1 with the mole, and now we have to come up with the molar mass of ammonium carbonate. And so we take attendance. That 2 distributes all the way through the parentheses. We have 2 ammoniums. So how many nitrogens do we have? We have 2. How many hydrogens do we have? We have 4 times 2, which is 8. How many carbons do we have? We have 1. And how many oxygens do we have? We have 3. Now that we have counted up the number of atoms that we have, we go to the periodic table and we look under the symbol and we find that nitrogen's atomic mass is 14.01, hydrogen's is 1.01, carbons is 12.01, and oxygens is 16. All right, so it's going to be 2 times 14.01 plus 8 times 1.01 plus 1 times 12.01 plus 3 times 16 to get the molar mass. And then that number is going to go in here. So I have not calculated this yet. Let's see. I'll go ahead and do that right now. And it's 84.11 grams are in a mole. So the molar mass is 84.11. That's how many grams are in 1 mole. So that 84.11 goes here in the denominator, which means we are going to take 325 and we are going to divide by 84.11. So in your calculator, put 325 divided by 84.11. And to 3 significant digits, we get 3.86, and that is moles. Okay, now this makes sense. 1 mole is like 84 grams or so, and we have way more than a mole. Okay, we have 325 grams, and so this answer makes sense. All right, let's try another problem. All right, this is a great visual, and it's not all that clear here, but I can show this to you in class. But if you've got mass, you're going to go to mole using molar mass. If you've got moles, you can go to volume of a gas here, or you can go back and forth here, and here's to particles. So let's try number 2. How many moles of nitrogen gas are in 135 liters of nitrogen gas at standard temperature and pressure? All right, step 1, start with what's given, 135 liters. We know we don't want liters anymore, so just immediately put it down there. Problem's almost half done. All right, what is our conversion factor? So sometimes, I'll look back and at that diagram I just showed you, and our conversion factor, and it's given to you in your reference packet, is that 1 mole has a volume of 22.4 liters. So what we do in this problem is we take, and now see our liters have canceled, you take 135 divided by 22.4. 135 divided by 22.4, and we get 6.03 moles to 3 significant figures. All right, let's try another one. How many molecules? Now this is not moles, this is molecules. Whoops, there we go. This is molecules. Okay, so it's a particle. All right, are contained in 55 grams of sulfuric acid. 55 grams of sulfuric acid. Do you remember your acid names? H2SO4, sulfuric acid, because that's sulfate. There's no way to go directly from grams to molecules, but we can go from grams to what? We can go from grams to moles using molar mass. So we're going to go ahead and put the grams down here so they cancel, and we're going to go to mole first. Can't quite get to molecules in one step here. If I take 2 hydrogens, 1.01, 1 sulfur, 32.07, and 4 oxygens at 16 each, that's 64. That molar mass winds up for sulfuric acid being around 98 grams. Okay, so that's the molar mass of sulfuric acid. So 55 divided by 98. Let's see what we get. All right, we get 0.561 moles of sulfuric acid. Again, a whole mole weighs 98 grams. This is 55 grams, so it's about a half a mole. There we go. But they wanted molecules, so we're not done. There's an extra step here. So now we are going from moles of sulfuric acid to molecules. Okay, so we're going to put moles down here. So we take this answer that we got in the first step, the number of moles that we have, and we're going to start with that. And in 1 mole, do you know how many molecules there are? 1 mole of anything is 6.022 e to the 23rd. Again, the moles cancel, and let's see what we have. Now we're going to get a big number because molecules are small. And I get 3.38, that is a 3, times 10 to the 23rd. Don't forget these exponents in your problem. All right, that's a lot of molecules, and it should be because molecules are small. So that's our final answer. All right. Let's just do one more quick practice problem. What is the volume of 2 moles of hydrogen gas at STP? Start with what's, oh my goodness. Sorry about that, guys. So we're going to start with what's given. And we are given 2 moles of hydrogen gas. And so we're going to immediately put moles down here, so they'll cancel. They want a volume. We do have a direct way to go from moles to volume, and that is using 22.4 liters in 1 mole. So here, the 22.4 is in the numerator. It's 2 times 22.4, or 44.8 liters. All right, I hope this has been a good review. Remember to use these steps. Start with what's given, then set up this conversion. Put the unit down here so it will cancel. Pick your right conversion, set it up the right way, and calculate. All right, we'll see you soon.